Okay, so we're going to talk about torque, and so it's sort of like someone said. Torque is sort of like a rotation. A torque is what causes a change in rotation. Kind of like what force is what causes a change in how an object is translating or moving from one place to another. A torque can change the way an object is rotating. Now take a look at this Ziploc lunch container, and it's got a lid on it. And so if I just apply a force to it, is that going to remove the lid? Well, let's try. No, it's not working. Why? Because I'm being stupid, that's why. All right, now what about this? I think you know that to open the lid, you grasp it from both sides and squeeze it and you twist. Now I'm applying a force with both my fingers. Here's these two fingers, and I like that. That's a torque. Now, what did these two fingers do to apply a torque? What if I push them in the same direction, like this? No, it's not twisting. It's not changing the way that lid is rotating. What I have to do is pull in opposite directions. This finger is going like this, while my thumb is going like that. See how that's in the opposite direction? And I just applied a torque to remove the lid. So we applied torque. Torque has all kinds of applications, whether you're moving a beam, making it rotate around a pin, or a gear that's meshed with another gear and making it rotate, or changing the way it rotates. Those are all applications of torque. So I think if you saw that, what did I have? Here's my Ziploc lunch container, and with my finger I twisted it like this. So I applied a force like this, and I applied an equal and opposite force like that, and that caused the lid to twist off. And so I think it makes sense, doesn't it, that a torque involves a force, but it's a twisting force. It's a force that wants to cause a rotation, not a translation. And something that you're going to have, like here's the center, you have the radius of this, and the radius is going to affect the torque. You have a radius. Now I'll give you the definition for a torque. We use this letter, tau, to represent torque. Tau stands for torque. And a torque is equal to the radius of my twist, in this case the radius of the lid, crossed with, or not, I won't use a cross product, I'll just multiply, times the force, this force, times the sine of the angle between the radius and the torque and the force. So look at this radius right here. From here, from the middle of the lid out to here. If I extend that out, that radius out, this would be the angle between the force and the radius. See, if I take that radius vector and I just move it like this, here's the force, here's the radius and vector, and you can see that it's 90 degrees in this case, isn't it? It's usually going to be 90 degrees in this class, because what are we usually applying torque to? Things that are circles, like wheels and gears and pulleys. They're circles. And so the force that you pull on it and the radius will always be perpendicular to each other. And so you've got the radius times the force times the sine of the angle between the radius and the force. And so let's say that this force, maybe it's if you have a chain, and this could be by the way, what could supply this force could be a chain on a sprocket. Well, the R would be the radius of the sprocket, and F would be the force that you're applying with that chain. Now let's say that a lot of times we use inches. Let's talk about units for a second. Units. Now, one of the things that you will find in using torque with English units, or I guess called imperial units, American units, stupid units, okay, is we'll quite often measure the radius in feet. And then force will be measured in pounds. And so you'll quite often hear foot-pounds of torque. They'll call it foot-pounds. Sometimes if the radius is really small, it'll be measured in inch-pounds. You'll see it, torque explained in inch-pounds. And I think it's really easy to see the unit conversion from foot-pounds into inch-pounds. There's 12 inches in a foot, so 1 foot-pound is equal to 12 inch-pounds of torque. In physics, in the sciences, and in those places where they use the metric system, thank you, they'll use Newton meters. Usually it's written as Newton meters, or sometimes you don't want to put meter newtons because it looks like a millinewton. Okay? So they call it Newton meters of torque. Now, Newton meters looks like another unit that we've used a few weeks ago. A Newton meter looks like a joule. But it's not a joule. It's a measure of torque. Torque and joules have this dimensionally the same units, but they're not the same thing. They can be. You can do work by using a torque, and we'll talk about that later. But a Newton meter is a unit of, and sometimes you can have Newton centimeters, or but notice that you're multiplying a force times a length. Force times a length. Length times a force. It doesn't really matter what order they're in. Now, let me show you. This is a very typical circular system. This is called a couple, a force couple. You have a force this way and a force this way. Notice if I add the forces together, you get 0. These are equal and opposite forces. So this doesn't cause the object to translate. It just causes it to rotate. Rotation. But you can have a linkage. Let's say you take a beam of some kind. And this could be like a beam on your robot arm. Let's say we build an arm. And I'm just going to draw it as a simple beam like this. This could be like a 1x1 extrusion or whatever you want to use. And you're going to pin it to like the base of your bot. Maybe here's the base of your robot. You pinned it right here. So that means that this arm can only rotate about this pin. It can't translate, right? It can't go back and forth. Well, what if, well, this has mass, doesn't it? This beam, it weighs something. And Jacob's in the other room, right? Yeah. So, but anyway, he's working on the Dock 7 arm. And so one of the big sources of torque for that is just the weight. Here's the weight, the force of gravity, the weight of that beam. You treat it like, you can find out where the center of gravity of that is, and then you just put it right there. And then here's the length. We'll call this L. You have to call it the length from the point of rotation to where that force is essentially located. And you say, okay, the torque on that is equal to L times the weight, what I've called L here, times the weight. And you can say, well, the angle is pretty much 90 degrees. So there's your torque. And that's the torque, that's one torque. We'll call this torque number 1. We'll call this L1. And but what if you had a cable on here? Maybe you're pulling on something. You have a cable. And so you have a tension force that's pulling up on this arm with the cable. And we'll call this force number 2. Well, what is the torque of that? The torque of that, and by the way, this is a Greek letter tau we use to represent torque. And it's kind of like a cursive capital T. Well, what is that going to be? Well, it's going to be, I'll call this L2. From the point of rotation, it's going to be L2 times F2. But notice something here. Look. See how there's an angle right here? An angle? Only the component of the force that's perpendicular to this length is going to contribute any torque. This force is pulling both horizontally and up. Only the upward component of that force contributes any torque. This part doesn't twist it. Only this part twists it. Does that make sense? Only part of it twists it. Well, what part of it is that? Well, it's the total torque. You learned this in your math class. This is the opposite leg of a right triangle. You get that by multiplying the hypotenuse times the sine of that angle. And that'll give you the torque for number 2. So, just to summarize, a torque causes a twist, causes something to change the way it's rotating. We use it all the time with gears and pulleys. And here's one way to calculate what a torque is. The force times the distance times the sine of the angle between the force and that lever. We call it a lever arm. And you can use this equation to solve torque problems, which we will do next time. So keep these notes in your notebook. That is all.